Okay, so Form 4 student, let's see. In question number 1, it said that we have 3 forces and the angle between them are as shown. So here you need to resolve the component that is perpendicular and parallel. At least you choose one force. Okay, so here I would choose the 20 newtons as the reference. So they would be perpendicular to, you have to resolve the component in these two. So the 10 Newton, if you have to resolve the component, it would look like this and this. And this one would be the angle between them is 10 degrees. And the 15 Newton, you would have to resolve it into this component and this component, okay, 15 Newton. And the angle between it would be 150 minus 90, so it's a 60 degree. Okay, so first of all, the force in this direction is equal to 20 Newton minus, because the direction of these two forces are this direction, minus 10 sine. So we are talking about this force here, sine 10 degree, and also minus 15 sine 60 degree. And we are talking about this force. Another force is pointing into, let's say, this direction. This direction would be 10 cosine 10 degree minus 15 cosine 60 degree. Okay, so F in this direction would be 10 sine 10 degree so it would be 5.27 Newton. And the another force is 10 cosine (2.348 Newton). So this square plus the resultant force is equal to these two forces acting together, right? So for vector sum, it would be the square of it, the sum of the square, okay? Then the answer of it would be 5.77 Newton. So the answer is D. This is a little bit complex, but I think some of you are still able to deal with this. Okay, so a box of mass 2 kg is hanging at rest. So this is weight, this is T and T. Find the horizontal string, the tension of the horizontal string. So which means we are trying to find us T2. Okay, T1, you can resolve the component into this direction and this direction. And this is 70 degrees. So this is T1 sine 70 degrees, and this one is T1 cosine 70 degrees. Okay, when we consider the vertical direction, upward equals to downward. Upward force is T1 sine 70 degrees equals to the weight, and the T1 cosine 70 degrees equals to T2. Okay, then this is the force pointing to the left and this is the force pointing to the right. Okay, you would have two equations here, 1 and 2. So 1 divided by 2, the tangent 70 degree equals to mg over T2. So, which means that T2 equals to mg tangent theta. it should be mg over tangent theta. Two times 9.81 divided by tangent 70 degree. Okay, so it is 7.14 Newton. So the answer is A. Okay, a box of mass 80 kilogram is resting on a horizontal floor on a helicopter. The helicopter is accelerating this one as a direction above horizontal. If no skipping occurs, find the magnitude of the friction between the box and the floor. So you may consider that the free body diagram of the box should be look like this, right? And the force is pulling the box to the right with the helicopter is the friction. So the friction is actually equals to the net force in the horizontal direction, right? So it is equals to ma cosine 60 degree. Okay? And then you will find out that the 80 kilogram times the acceleration 2 times cosine 60 degree. Which means that the friction is actually 80 Newton. Here, A. Okay. Okay, it said that in section B, short questions, it said that in the following experiment, a trolley of mass 0.5 kg is placed on a smooth inclined plane. It is connected or to a box of 2 kg through a tight, light inextensible string over a body. So at t equals 0, the system is released from where a velocity time graph is plotting using the data collecting by the motion sensor. So it said that you have to solve the acceleration of the trolley from t equals 0 to t equals 5 seconds is 0.406 meter per second square. Now, weight of B, tension, and then this one is tension, weight of A, and the normal force. So if you consider A as one object, consider both of them the same object. So you would have one force is weight B pulling it to the right, and one force is the weight A sine theta pulling it to the left. So and it is pulling both objects. Then you can use 0.2 times 9.81 minus 0.5 times 9.81 times sine 20 degree equals to 0.78. Then the acceleration, you'll be able to calculate it as 0.406 meter per second square. Okay, so state and explain one assumption on your above calculation. Now, some of you states that there are no air resistance. I think it's okay, but actually the air resistance in these cases is quite small, okay, to affect the motion. But however, you can see that it said that it is using a poly, okay. But normally, when you see the questions, it will say that it is the friction between it is a smooth poly, okay. So some of you say that about the friction, but it's already stated that it is a smooth surface, so no need. However, because the questions does not state that the poly is smooth, so in your calculation, you ignore. You have assumed that there are no friction coming out from the poly, okay? because the question does not state that the poly is smooth. Okay, so therefore if the poly is smooth, so which means that the tension the same. Okay, so the box B hits the ground as t equals to 5 seconds, estimates t log. Now, consider that the box B already hits the ground, okay? So, the string would become loose, so there would be no tensions there, okay? So, only for A, there are only two forces acting on it. This is the normal force and the weight. Therefore, the acceleration of the truck will be in this direction. Sine 20 degrees. Okay, and the velocity at t equals to 5 seconds, it would be the original acceleration because it is accelerating by this, okay, in this part. Then you apply V equals to U plus AT. The final velocity is 0 because it would be at rest and yeah. Okay, so and then this one is 2.03 plus the so therefore the T log here will be equals to 0.61 second, and then so the time taken for it to become at rest will be different. However, you can see that when we calculate it, we are talking about this is t, okay? So t log is equals to t plus 5 seconds.